Hi everyone, this is going to be part 2 of the introduction to masonry. We're going to talk about contemporary masonry elements and contemporary building structures. The contemporary masonry elements, there's common masonry elements that are used that today that differ in detail from those used in ancient masonry buildings. In this section, we will describe the various types of walls, columns, pilasters, beams, and lintels that are used, and in later sections, we will discuss the design of these elements. So the first thing that we're going to talk about are walls. The function of a wall is that it carries the load, and its location in the building is a factor in choosing what type of wall we need. Walls are normally constructed in running bond, and this produces a familiar symmetrical overlapping pattern over the face of the wall, which means is basically um, the block on top is always placed halfway on the other block on the bottom. This is the most common, being a half bond method that we use. So the joints position at the middle of the unit below, and they keep on going to build a wall unit. A single width wall. Single width walls have thickness equal to the width of the masonry unit and can be constructed of solid, cord, or hollow units with or without reinforcements for either load bearing or non load bearing applications. So you'll see in in these slides going forward, we're going to use single width walls as an example for a single thickness masonry unit, and then it will be converted into cavity walls, solid walls, inside walls, outside walls. The next is the solid um, and composite walls. Solid walls have two or more closely placed widths, single wall widths connected by masonry units called header or by reinforcement wire. So we can either use a header, which is a block that goes across, or reinforcement wire. So it could be sort of any tiebacks that you could use. When the widths are spaced 10 to 20 millimeters apart, the collar joint between them is filled with mortar, right? And if it's more than that, if it's in 50 to 75 millimeter wide opening, the cavity is constructed and later filled with grout to form a grouted wall. Now we'll go into details of grout and mortar later, but we cannot use grout instead of mortar and vice versa. They both have different functions and they both have different requirements when we use them. So they have a different slump, therefore they cannot be interreplaced. So we'll get into details of mortar in the next slides. So here you can see load bearing and non-load bearing. So they can be there. Here you can see the metal ties on these that are they're used to combine these two widths, right? And here you can see a masonry header on the drawing up here, on the diagram up here. It's a masonry header. It's a block that goes across two widths and it combines the two blocks together. A solid composite wall. A header is a masonry unit that's laid in the length of the wall, and the widths of dissimilar materials are joined together to form a composite wall. So you can have a clay brick that can be used on the exterior face and the concrete block that can be used in the inside face. So you can see here you have a clay brick and a concrete brick on the outside. Sorry, clay brick and a normal brick on the outside. And that's the facing, and the inside is the structural clay tile. And then you have two clay tiles here, and you have two masonry bricks here, but you have a masonry brick and a composite to create a composite brick. Here you can see there is a header unit that is going inside, and that's to combine the two. So solid wall and composite walls are very typical wall types that we use in masonry construction. The inside wall is usually for structural purposes, and the outside wall is usually for veneer. That's for to look pretty, basically. Cavity walls. In cavity wall construction, basically there's two widths or widths that can be of similar or dissimilar materials, and the cavity is unfilled. If properly constructed, the cavity resists the inboard movement of moisture from exterior into the interior by providing a drainage plane. and serves basically as a capillary. So the water is broken and it goes down, and then there should be some sort of drainage at the bottom where the water can be taken out of the structure. In most applications, I know why it supports the weight of the floor. So basically, it is the one inside is the structural. So for example, in this case here, you can see that the solid masonry block in the back is probably the structural wall, and you have these ties that are connected to the brick on the outside. So that's an example of cavity walls. Then you have veneers. So masonry veneer consists of non-structural masonry with anchored to a structural backing. So here you can see this is a brick veneer wall, and inside is a normal or wooden frame. The masonry veneer is used for its aesthetic and durable qualities, and not relied on to resist lateral or axial loads. So basically, it's just there for the outside aesthetic purposes. The structural backing may be masonry, concrete wall, or framed wood or metal wall. Masonry veneer is usually tied to the backing with metal ties. So you'll see in here, it is tied by metal ties, and you have a 20 to 40 millimeter spacing between the veneer and the backing. So in Canada, for most of our construction, or most of the houses that we built here, most of them are built with veneer walls. So the brick outside, they are not structural. Most of the structure inside is all the wooden structure, and that takes all the loadings. The outside veneer wall is just to look nice, and it gives you the opportunity to use different types of bricks, different colors of bricks. It is basically for aesthetic purposes. And it also has durability qualities that if it does not rot that fast in rain, snow, so it is durable and provides that security from the outside. A diaphragm wall. A diaphragm wall can be thought of as a form of a hollow wall or cavity wall in which two whites are connected by masonry webs. So basically, they have walls inside of a wall. Just to show you that, just to explain that, so you'll have two walls that are interconnected with a wall in the middle, is I guess the best way of seeing it. So a composite action by two widths greatly enhanced by flexural resistance and allows the diaphragm to span. So basically, it can span larger distances and resist greater lateral loads. So you can see here there are two widths, and in between there's almost like a small wall. They're interconnecting it together, right? And then the widths continue, and there's a small wall. So this gives it the more lateral flexural resistance. Then you have columns. Masonry columns are basically isolated vertical structural beams, members that transmit the dead load and live load from to the foundation. So from the structure above, they bring all the loads down into foundation. It's similar to the columns that we have done in concrete design. So it has the same functions. A column is usually in masonry. They're usually rectangular cross sections, and the length is no more than 3 times its overall thickness, and the height is greater than 5 times its overall thickness. So the height here is 5 times the thickness. Let's assume this is the thickness. The height is needs to be more than 5 times the thickness, and the length no more than 3 times the overall thickness. So you can go 3 times the overall thickness, because then it becomes almost like a wall. So the design criteria are then become a little different. Pilasters. Basically, pilasters are columns that are incorporated into the wall. It's a thickened wall section built integrally with the wall, and is sometimes described as an engaged column. The pilaster can project out of the wall on one or both sides, and can be connected to the wall by headers or bonds. So here you can see this is a wall section, and you have this pilaster coming out. It's in this situation, it's reinforced. It can be reinforced or unreinforced, and these are used to give more lateral support to the wall itself. Uh, Actually, the pilasters can perform four functions. They act as a column to support beams, trusses, and other structural members. Pilaster can help support a slab or other uniform load by increasing the wall's resistance to buckling. And they can act with the wall as a flexural member spanning between the top and bottom support to resist lateral loads on the wall. So if you see a wall like this, after a certain length, you'll put a pilaster, so just to give it more lateral supports. And the pilaster can be used as small buttresses to increase the stability of the freestanding wall. So like you can see here, it is a freestanding wall. Let's say it's a boundary wall, freestanding wall. It is giving it more stability as a buttress. So these are the four main uses of pilaster in walls. Beams and lintels. This is something that we're going to go into a lot more detail in masonry construction. There's roof beams, floor beams, bond beams, and grade beams. Just to show you an example, this is a lintel block. So it is a solid block which is hollow from the top, but there's no hollow sections in the middle. That's why it's a lintel. And a bond beam block, it's basically a masonry block, but it is cut out for reinforcements to be placed. So here you can see in this picture, you can see the reinforcements going through. There's also vertical reinforcement and horizontal reinforcement. So these blocks are cut out so that they can take both vertical and horizontal reinforcements. Bond beams are usually located at the roof and floor levels and serve dual function of tying the building around the perimeter. The action as a cord member in floor or roof diaphragm to transmit lateral loads to the shear walls. So these walls are bond beams are usually right below the floor, right? They go right below the floor, right across below the floor, or right on top. Those are where bond beams are located. Lintels is a horizontal beam spanning over a door or window opening, and it supports the load from the wall above. So usually a lintel is a solid beam. It can be either or. It could be solid beam, or you could have masonry units with reinforcements, but usually it's for a window or door opening, it's usually a solid beam. You can see here, like here, you have a solid beam going across, then you have masonry units on either side. We will go into detail, but the loading on top usually goes in a rectangular format when we do the loading check on lintels. So the iteration diagram, you'll see it comes like a triangle on top. We'll get into detail when we go into designs of lintels and beams. Next is all masonry beams must be reinforced because the limited tensile strength of masonry should not be relied upon to resist fractional tensile stresses. So similar to concrete, we need to have reinforcement in the beams. And then there's also stirrups that are used if you have steel beams on top and at bottom. So depending on the weight that depending on the stresses that this beam is going to take, we also have stirrups that go along the top and bottom to connect the two reinforcements going across. Now let's get into contemporary masonry building systems. The masonry element previously describes are combined into all of them. They combine and we put them into a masonry building system and can be classified into the three systems: single-story load-bearing buildings, multi-story load-bearing buildings, and hybrid buildings. Single-story load-bearing buildings make up a majority of the load-bearing masonry construction. These are basically typically your warehouses, your industrial buildings, your gymnasiums, banks, commercial stores. Small buildings, one story high. They're usually mostly cost efficient most economic and cost efficient to make unreinforcement walls, and they have to be they are laterally supported. A lateral support along the top is provided by the roof or the floor system, and they are pretty typical construction in a lot of the world, in most places, such as in the warm parts of the US and a lot of Asian countries. In Canada, we don't really do brick construction as much because like we said before, it's usually the material that you use that you have locally. In Canada, we or in Northern America, we have a lot of wood available, so we do a lot of wood construction compared to masonry construction. Then you have multi-story load-bearing buildings. In this type of construction, masonry walls support a concrete floor, which in turn supports the next story of the masonry wall placed directly in line. The concrete floor slabs acts like a rigid diaphragm, so it all connects into each other. And the contemporary load-bearing masonry build construction resists overturning by the walls placed parallel to the wind direction. So here you can see that you have a load-bearing wall, a wall which has a slab on top, and then you build another wall on top, and then you build another slab, and that's how it takes all the loading, lateral loading on that. Hybrid buildings. Masonry can be used with other materials to form hybrid buildings. So you can have load-bearing masonry wall can have utilized in exterior walls in steel systems or as a service shaft in stairways and as shear cores to resist lateral shear load. So masonry is really good or is has good qualities for lateral shear loads. It's very good at resisting those. Another example is infill frames in buildings where masonry infill walls provide stiffness to control building drift. So if you just have these steel beams sticking out of the ground, the the whole building will be moving, right? But if you put this wall system inside this this steel frame, it stiffens the structure, so it does not move as much. Uh, Masonry walls are used a lot in areas where there is a lot of earthquake activity because they act really well in transferring the lateral loads that impact the building due to earthquake structures. I think this is it for contemporary masonry building systems. Next, we're going to talk about some design criteria and requirements, and we'll be sharing those slides and videos shortly. Thank you, guys.